Hello and welcome to A-Level Math. This video covers some basic concepts of coordinate geometry because in the upcoming videos we will be discussing about the concepts of straight lines, circles and many other topics of coordinate geometry. So in this video we are going to cover up the distance formula, the area of triangle and section ratio. So let's get started. So the distance formula means that suppose you are given 2 points on the Cartesian plane. So suppose this is your Cartesian plane and you are given 2 points, someone over here and someone on here. So suppose that this point over here is given by x1 comma y1, so it could be like 2 comma 3, 5 comma minus 2 or anything, and suppose that this point is x2 comma y2. Now you want to find out what is the distance of this point from this point. Okay, so what do? We draw perpendiculars from these 2 points, and we also draw a perpendicular from this point on this perpendicular. So let's call this point as L, this point as M, and this point as P. Alright, and let's also call this point something like Q. Okay, and this point is R, no problem. So our final task is to find out the distance QR. Okay, this distance QR we need to find out. Alright, so what is the coordinate of L? L is of course x1 comma 0, because we are only traveling a distance of x1 units, because this point is x1 y1, right? So what does that mean? It means that you are traveling x1 units along this line. So you are traveling x1 units over here and y1 units over here. So if you're traveling x1 units over here, then this point is x1 comma 0 and this point is x1 comma y1. So that's how we get L, and similarly we can write M as x2 comma 0. Alright, so what is this distance LM? LM is of course this entire distance, which is x2 minus x1, because this distance over here is x1. So this entire distance minus this distance gives us the length of LM. So we get LM is equal to x2 minus x1. Now because LM is actually equal to QP, because actually LMPQ is a rectangle, so PQ is also equal to x2 minus x1. Okay, perfect, no problem. Now what about this distance PR? Okay, so now you know that MR is actually y2, because in order to reach the point R we travel x. Okay, let me clean some stuffs over here for your better understanding. So in order to reach this point R, you have to travel x2 units along x-axis and then y2 units along the y-axis. So this entire length from R to M is actually y2, and this PM is y1. Why? Because PM is actually equal to QL and this height is y1. Okay, so this PR is this entire distance y2 minus this distance y1. So I get PR is equal to y2 minus y1. Okay, no problem. So now what we have at hand is that we have a right angle triangle with perpendicular and base. So applying Pythagoras theorem, I can find out QR, and which is the required thing. I need to find out QR. So using Pythagoras theorem, I know that QR square, which is perpendicular square, is QP square, which is base square, plus PR square, which is perpendicular square. So QR square we need to find out. QP we have already found out. QP is x2 minus x1. So this whole squared, and PR also we have found out, which is y2 minus y1 and the whole squared. So QR is actually equal to root over this entire thing, x2 minus x1 whole square plus y2 minus y1 the whole squared. So this is the distance formula. What this formula says is that suppose that you are given 2 points x1 y1 and x2 y2, you just put down these values over here and you can find out the distance between these 2 points. So let's apply this formula to find out the distance between these 2 points, 2 comma minus 3 and minus 6 comma 3. Okay, so think of this 2 as x1, this is y1, this is x2 and this is y2. So the distance, let's assume that distance is given by small d, is given by root over x2 minus x1, which is minus 6 minus 2, x2 minus x1 minus 6 minus 2 the whole squared plus y2 minus y1. So 3 minus minus 3, which gives us 3 plus 3 the whole squared. On simplification, it gives us minus 6 minus 2 is minus 8, minus 8 whole squared is 64, plus 3 plus 3 is 6, 6 whole squared is 36. So I get root over 100, which is 10. So 10 units is the distance between these 2 points. Okay, next question. Using the distance formula, prove that these points A, B and C are collinear. Okay, so what is the condition that 3 points are collinear? So suppose that A is over here, B is over here and C is over here. So this is my A, this is B and this is C. For these 3 points to be in a straight line, I need that distance of this point from this point, distance of A to B and distance of B to C. If we add these 2 distances up, it actually gives me the distance of A to C. So if I can prove that AB plus BC is actually AC, then I can show that the 3 points are collinear. So I leave this thing to you as an exercise. It's just the application of this formula. It's a very simple application. Find out the distance of AB. You have the coordinates A and B. So think of this as x1, x2, x1 and y1, and this is x2, y2. So you can find out the distance of A and between A and B. Similarly, you can find out the distance between B and C. Assume that now these points are x1, y1 and these points are x2, y2. So in a similar fashion, you can find out the distance between B and C. And also in a similar way, assuming that A is x1, y1 and C is x2, y2, you can find out the distance between A and C. And just verify whether distance between AB and BC turns out to be the distance between AC or not. If it turns out to be, then yes, they are collinear. So try it out. Next topic is the area of a triangle. Okay, so suppose that you are given the 3 vertices of a triangle, x1, y1, this is x2, y2 and this is x3, y3. Okay, so assume that these are the 3 vertices that are given to you. Now we are interested in finding out the area of this triangle. Okay, so first of all, let me tell you the answer. I mean, how do we actually find out the area given these 3 points, and then I'll just give you some basic hints of how to prove that formula. I won't be going into the exact proof because I think you might not be interested in it. If you are, then just see the video and then go to any standard textbook. You will find the proof over there, and I'm just here to help you to understand that proof. Okay, so first of all, I'll tell you with an example of how to find out the answer. Let's just take up an example first. Find the area of triangle with these 3 points as vertices. Okay, so what you need to do, you start with any particular point. So let's just take the first point itself, 4, 4. What do? You write down 4 over here. The next point is 3, minus 16. So you write down 3 and minus 16. Then you write down 3 minus 2. So you write down all these 3 points and then just repeat the first point again. So it's 4 and 4. Okay, so it's not necessary that you have to start with A only. You could have it also written it like in this fashion, 3 minus 16 and 3 minus 2 and 4 and 4. You just need to repeat the first one, 3 and minus 16. So you can go in any order as you like, no problem with that. Okay, so once I have written this, then what is the area? You have to write down half. This half will be always there, and then a mod. Mod is something I'll tell you what to do with it. Mod is the absolute value function. Okay, so what you need to do, first of all, you multiply this with this plus this into this plus this into this. So what we have to do, first of all, we have to write down 4 into minus 16, 4 into minus 16 plus 3 into minus 2. So what we have done is 4 into minus 16, then 3 into minus 2. So 3 into minus 2, then plus 3 into 4 plus 3 into 4. So you find out what this value is, and then what you need to do is subtract something. What do we need to subtract? We need to subtract this into this plus this into this plus this into this. Okay, so we have to do 3 times 4 plus 3 times minus 16 plus 4 times minus 2. So we need to simplify this and find out the answer. I'll tell you what the mod is, just bear with me for some time. Okay, 4 times minus 16 is minus 64, plus 3 times minus 2 is minus 6. Multiplying with this plus gives us minus 6, plus 4 3s are 12. So this inside a single bracket, alright, and then minus 4 times 3 is 12, plus 16 3s are 48, so minus 48. So plus into minus gives us minus 48. 4 times minus 2 gives us minus 8, and inside a mod, everything inside a mod. Half, so minus 64 and minus 6 gives us minus 70, plus 12 is minus 70, minus 60, minus 58. So this gives me minus 58, minus minus 48 and minus 8 gives me minus 56, and then plus 12. So subtracting we get 44, so I get minus 44. So minus 44, so this gives me plus 44, which is equal to half. Then 44 minus 58 gives me 58 minus 44 gives me 14. So this gives me minus 14. Now this is where mod comes into picture. So if you see something negative inside mod, just change it into positive. In fact we have already discussed this thing in our function series. So if you haven't seen that, please go and watch my functions, sets, relations and function series on A-level math. So what you need to do is that you just need to convert everything into positive. So if you're getting minus 14, just make it as plus 14, and if you're getting 14 then it's fine. If you're getting something positive, it's fine. If you're getting something negative, just make this positive. This is what this modulus means. This modulus means that you have to turn it into a positive number. So this gives me my answer as 7 square units, whatever it is, centimeter square, millimeter square, whatever it is. So this gives me 7 units squared. So this is my answer. Alright, so now I was saying that we need to prove something. So how do we reach this formula? I mean, how do we know that we have to do this into this, plus this into this, plus this into this? So there's a formula for it, right? So what do we need to do in order to reach that formula is just that you see that this is a trapezium. This entire thing is a trapezium, alright, because this side is actually parallel to this side. So what is this length? This length is x1 minus x2, in the similar way as we discussed in the previous video, because this length is x1, because this point over here, this point is x1 and this point is x2. So this distance is x1, this distance is x2, so this remaining portion is actually x1 minus x2. Okay, so let me clean up something. So what I get is that this distance is x1 minus x2. So I've got this distance. Now what is the area of a trapezium? Area of trapezium is half into sum of the parallel sides into the distance between them. So this distance is y1 itself, sorry, y2 itself, and this distance is y1 itself. So the area of this trapezium can be found out as half times sum of the parallel sides, which is y1 plus y2, y1 plus y2, times the distance between them. Distance is this distance, which is x1 minus x2, x1 minus x2. And similarly, just let me clean up something. Similarly, you can find out the area of this trapezium. Just a second. Yeah, so this is another trapezium, this is another trapezium, and in a similar way you can find out the area of this trapezium, which will be half times sum of the parallel sides, which is y1 plus y3, times the distance between these two will be x3 minus x1, so it is x3 minus x1. Okay, so this trapezium has got this area, and there is one more trapezium. One more trapezium is this trapezium, right? So this trapezium has the area equal to half times sum of the parallel sides, which is y2 plus y3, y2 plus y3, times the distance between them is x3 minus x2. So it is x3 minus x2. Okay, now that we have got the area of trapeziums, now what to do? So if you see the area, we want the area of this triangle, right? So the area of this triangle is actually equal to the area of this trapezium plus the area of this trapezium. So you have got this entire portion, but then if we just subtract the area of this trapezium, then what we are left with is actually the area of the triangle. So what do we need to do? We just have to add this and then subtract this third trapezium, which will give me the area of the triangle. So this is how you should approach. So you go to any standard textbook, you follow the proof, and you will see that the final area, the formula for the area that you come up with is actually the thing that we have been doing. So even if you're not familiar or not understanding the proof, no problem. You have already understood, given any 3 points, how we are actually calculating the area. That's just enough, because it is very rare that the examination is going to test you on the understanding of the derivation of the formula. So you can just take my words that you don't need to actually derive it, but still, if you are very much interested, I would request you to go through that proof. But otherwise, just remembering what we are doing to find out the area is sufficient. Okay, section ratio. So section ratio means that suppose you are given 2 points. So let's again take these as x1 and y1 and x2 and y2. So these are my 2 points, and let's join these 2 points. And suppose that there is a third point which we call as x comma y. This point divides this line segment in the ratio m is to n. So we need to find out what is the what are the coordinates of this point. So to find out the coordinates of this point, we have the formula x is equal to m x2 plus n x1 by m plus n, and y is equal to my2 plus ny1 by m plus n. Now what just happened? Okay, so let me explain you something. This formula says that suppose there are 2 points and the third point divides these 2 points in the ratio m is to n. So this could be 2 is to 3, 1 is to 2, 4 is to 5, anything. So in order to find out the coordinates this point, so to find out this thing, what you need to do, you multiply m with this x2 and this n with this x1. So this kind of crossing, you multiply what's on the left with what's on the right. So mx2 plus nx1 divided by the sum of the ratios. And similarly, if you want to find out this y, then what you need to do, multiply the m with this y portion and n with this y portion. So it's again like multiplying in a cross way. So my2 plus ny1 by m plus n. This is how you get the coordinates of this point. So let's take up an example, and then for those who are interested, I will tell you how we actually derive that formula. Okay, so first example, we have a point A and we have a point B. Suppose this is a point A, this is the point B. This is 5 comma minus 2, 5 comma minus 2, and this is 9 comma 6, 9 comma 6. So we join these 2 points, and then we have the ratio given to be 3 is to 1. And we have to find out this point x comma y. So let me read out the question for you. I'm sorry that I forgot to read it out. Find the coordinates of the point which divides the line segment joining these 2 points in this ratio. So it's again actually the same thing. You have to find out the coordinates of that point which divides the line joining these 2 points in the ratio 3 is to 1. Okay, so we know that for finding out x, what we need to do is multiply this 3 with 9, multiply this 1 with 5, and then divide by 3 plus 1. So it's 3 times 9 plus 1 times 5 divided by the sum of the ratio 3 plus 1. And to find out y, we have 3 times 6, 3 times 6 plus minus 2 times 1 divided by 3 plus 1. So you just need to simplify. 9 3 is 27 plus 5 is 32 by 4 is equal to 8, and this is 6 3s are 18 minus 2 gives us 16 by 4, which is 4. So the coordinates of this point is 8 comma 4. So this is the point which divides this line segment in the ratio 3 is to 1. Okay, so now for those who are interested, I'll just tell you how we actually derive this. So again, let's draw our coordinates. So this is my point x1 comma y1, and this is my second point x2 comma y2. If you are not interested, you can just skip and forward this part. Okay, so we want to find out some point x comma y over here which divides this line segment in the ratio m is to n. Okay, so now what we do, we draw perpendiculars. So this first perpendicular, this is second perpendicular, and this is my third perpendicular. So this length is y1, this also is y1, this entire length is y2. So this small bit over here is y2 minus y1. Okay, and also let's drop a perpendicular from this point x comma y. So we have another point x comma y, and we have to find out this distance and this distance. So this distance over here is actually x minus x1, and this perpendicular distance is what, y minus y1, y minus y1. Okay, now if you observe that this triangle and this big triangle, if I name these as A, B, C, D and E, then triangle ABC is actually similar to triangle ADE, and using similarity I get that AB by AD is equal to BC by DE is equal to AC by AE. This is I get from similarity, and from here whatever values you know in terms of x and y, you just put down these values and simplify. I'm sure you're gonna get the answer. So okay, let me help you also a bit. So if you see AB, we are not interested in AB, we are not interested in this length, so we don't need actually this part, just concentrate on this and this. Okay, so what is BC by DE? BC by DE is y minus y1 by what is DE? It is y2 minus y1, which is equal to what is AC? AC is actually this length, which is x minus x1 divided by what is AE? AE is actually equal to what is it? It is x2 minus x1. Okay, x2 minus x1. Alright, now what about M and N? What is M and N? M and N is actually AB by AD, right? So this actually AB by AD, this helps us to get the M and N in the picture. So AB is actually M by AD is M plus N. Now if you take up this part, you will be getting a formula for y, and if you take this and this, you will be getting a formula for x. So you will be getting y is equal to mx2 plus nx1 by m plus n, and you will be getting x is equal to mx2 plus nx1 by m plus n. So you just simplify them and find out the answer. Okay, now one more question. In what ratio is the line joining this and this divided by the line this? Okay, so let me make you understand the question first. So there is a point A and a point B. This point is minus 1 comma 1 and this point is 5 comma 7. Now they are joined. So the question says that in what ratio this line segment, this join is divided by this line. So x plus y equal to 4, assume that suppose it goes something like this. So this is the line x plus y is equal to 4. Now we have to find out in what ratio is this line cutting this AB. So assume that it is cutting in the ratio m is to 1. Now why m is to 1? Because suppose even if I take m is to n as the ratio, what I can do is I divide both side by n. So I can take this m by n as my something like k is to 1. So it's not necessary that you always have to take your ratio as m is to n. You can also take it as m is to 1 or k is to 1, because it is always possible for you to write it down in that format. So it is always possible to do that. So I assume that my ratio is m is to 1. It will simplify things because I only have one variable to find. I just need to find out m. Okay, so assume that this point is x comma y. So what I can do is just write down x is equal to m into 5 plus 1 into minus 1 divided by m plus 1, and what is y? Y is equal to m into 7, just crossing m into 7 plus 1 into 1 plus 1 into 1 divided by m plus 1, sum of the ratio. Now this point lies on this straight line, right? So it must satisfy this equation. So that means if I do x plus y, I should get 4. So this is how I get an equation in terms of m. So I get 5m minus 1 divided by m plus 1 plus 7m plus 1 divided by m plus 1 is equal to 4. So this will give me the value of m. I take m plus 1 as my LCM. 5m plus 7m gives me 12m minus 2 is equal to 4. Simplifying, I get 12m minus 2 is equal to 4m plus 4. I take m on one side, so 12m minus 4m gives me 8m is equal to 4 plus 2 is equal to 6. So m is equal to 6 by 8 is equal to, I can cancel it with 2, so I get 3 by 4. So I get the value of m as 3 by 4. So this is what the beauty of taking m is to 1 is. So I have the ratio as m is to 1. So m is 3 by 4. So 3 by 4 is to 1. So the ratio is actually 3 is to 4. I can multiply on 4 with on both the sides with 4. So I get the ratio as 3 is to 4. So you see that even if we take m as m is to 1, so our final answer can come in something like 3 is to 4 or 5 is to 6. That's the beauty of, and it makes things so much simpler. We just have to find out the value of m and we are done. And we are done with the entire tutorial also. So thanks a lot for bearing with A-level maths. Study hard, study smart. We will see you in the next video with straight lines. Bye bye.